Welcome to ICE Education, the only education that matters. It's been almost a month that I haven't introduced myself like this. Okay guys, thank you for choosing ICE Education. What we are doing today is called Laplace. So yesterday, if you remember, we've done an introduction about Laplace. That's why I give time for people to join so that I don't have to come back like this. Please, let's make sure that we all on time so that we don't have to be going back and forth. Okay, yesterday we had an introduction where we did introduce Laplace. So today we're going to move to what you guys will be dealing with on this Math 4 as first chapter, Laplace. So what is the first thing that we'll be doing tonight? It is called the first translation property. That's the first thing that we'll be doing tonight. Who's joining again here? Zime Mengezi. Welcome, Zime Mengezi. Okay, if you do remember yesterday, we've done something like this, where we just had to use the formula of the Laplace. So that's one of the reasons I say like we should join on time. Otherwise, I'll keep going, adding and coming back, and it's disturbing for some people. So please, let's make sure that we're on time so that we can avoid that. Okay, literally yesterday we've done something like this. What we had to do was to write the formula and to solve the Laplace as simple as it could be. And what I want us to do today is the first translation property. That's what I want us to do. Next is, I'm gonna add this guy now. Mr. Poppy, please, let's be on time. The next thing is going to be the change of scale property. What is mostly important, guys? Laplace transform of integral. So tonight we will make sure that we reach these three. We do some couple of example, and you can ask question, and yeah, we move forward. So this is what's gonna happen now. So for a quick recap, for those who might miss the class yesterday, I can just solve again this example quickly, just to bring everyone in the mood and see how Laplace work. As easy as that. Yeah, this is it. This is the equation. Okay, why is it too big like this? Why is it too big like this? Anyway, I'll try to recap something like this. Minus 3 exponential minus 2t plus 5 sin. For those who were yesterday, my tablet is on repair, so from next week I won't be using my mouse. We won't have this challenge, so just mind my handwriting for now. We should be fine by next week. Okay guys, this is literally what we have. And yesterday we had something like this. It's just a quick revision before we move. If you want to solve this Laplace here, remember this. How do you deal with it? You can solve it separately. You can write each expression with its own Laplace. It's just a quick recap. I can write it like this: Laplace of minus 3 exponential minus 2t, like this, plus Laplace of, you can give each and every expression Laplace. Is just a quick recap before we proceed to what we're gonna do tonight. Sin of 3t. I don't know if you remember, yesterday we did something like this. And how do you solve for this? This is the formula sheet, as you see on the left, this one here. It will be provided. And I said, whenever you solve for the Laplace, what do? You look at the formula on your left and your answer is on your right. Like for instance, I want to solve for this expression here. And what happened to the integral rules is also the same here. I don't know if I'm making sense. When it comes to constant, remember, if you're having, let's say, integration of 2x in terms of dx, you can write it as 2 outside integration now of x in terms of dx. So this rule here is the same also in the Laplace. So you can take this constant out. So you can have minus 3 out of the Laplace, so that you can have simply Laplace of exponential minus 2t, like this, plus, mind my handwriting, we won't be having this challenge by next week. Who wants to join now? Please, please, Mr. Innocent Mabaso. Next time, let's be on time. Let's be on time. So what's happening here? I'll write 5 outside, so I have Laplace of sinh 3t. Yeah, this is very challenging like this. I need to get my tablet next week. Now, what's happening here now, guys? After writing like this, now you can solve for Laplace. How do you solve it? You simply go to the formula sheet, you identify where you are, and you write the solution. Like we are here, I'm on exponential. Where is exponential? This is exponential, the formula, and this is the answer. When you solve for the Laplace, you move from left to right. When you solve for inverse Laplace, you move from right to left. But you will see it when we get to the inverse Laplace. Now, as I am on this case, what do I have to know here? I can simply recall here minus 3 multiply. Now I write the answer of this Laplace. According to this, the answer is 1p minus b. So you have to be able to identify which one is your b. In this case, our b is minus 2, as you can see here. So what do? I will have 1 over p. There is minus of the formula, and the minus 2 coming. We did it yesterday, which makes this plus 2 like this. Now you are done. You have 5 outside here. You solve also for the Laplace of sinh 3t. How do you get sinh? You come to your formula sheet. Which one is it? It is this one here. So you move from left to right. All you have to do is to copy and paste the formula, as easy as you can see it. So how do we do that? The formula of sinh is a p square minus a square. And guys, if you feel like I'm too fast or I'm speaking whatever you don't understand, please call it. Please call it and stop me, because there is a target that we have to reach tonight. Now I have 5 sinh. Sinh is this one. They say it is a. Which one is my a? You have to be able to identify a in this case. A is the constant inside the C here, which is 3. So can we write it down? We're going to have, you can open your bracket. What is a? A is 3. You just copy 3 over. The formula says it is p square minus a square. So it is p square minus a square. A square, it is simply 3 square. So if you can do this, guys, I'm pretty sure your final answer here will be, if you multiply out, you have minus 3 p plus 2 plus 5 times 3 is 15 plus 15 p square minus 9. So this is just a quick recap of what we did yesterday. Now we have to move to what we have to do tonight. I'm pretty sure that's what they got as answer. Okay, guys. Next thing here is what they call the first principle of translation property. I'm pretty sure if you look at this expression, let me show you. It is E. The expression here, it is E5t. Let me write it down. They want you to solve Laplace of exponential 5t cos of 2t. Guys, if I ask you to solve for this, what will be the first thing that you do? I'm pretty sure that I have this under my formula sheet here. Do you guys see it? Hello? Guys, please, don't make me feel like I'm alone. Please, just speak to me so that I feel like I'm interacting with...
Number 12.
Okay, it's number 12. Okay, this is when you solve the Laplace, you pick the formula and you just paste the answer. But if you are being asked to use the first translation property, how do you solve that question? I don't know if you see the difference. If I said solve Laplace, use the first translation property. Sorry guys, let me just take this quick, please. Yes, Allah. C'est moi là, c'est moi là. Côté de la cimetière, vous pouvez venir. Vous pouvez payer ma adresse ici. Makulu. Vous pouvez Makulu. Guys, ça va pas vite. Elle a un cimetière, je crois pas que c'est trop safe la nuit. Non, viens pas qu'il y ait un zila et catch. Tu nous as laissé les amis dans zila catch. Zila. Ok, tu vois, voilà, zila facile. Déjà, extra clothing. Tu vois le robot roundabout. Si tu veux elle est dans rond-point. Yeah, tu prends la droite, tu montes straight. Yeah, tu vois le premier rond-point là, ça te mène, elle a check out sa jean, or elle descend, elle y a foot over, maintenant straight up. Yeah, straight up, c'est là-bas, quand même. Si, qui m'a dit Einstein, c'est français. Yeah, up. Et comme nous avons pas de lien, nous avons pas après à la base de Okay, sorry, my guys, I just had a call. Okay, we are back. What I was trying to say is, whenever you have a question, please pay attention to what is being asked. Because if I ask you to solve this question here, you will literally come and put this formula here. If I said solve Laplace of this function, you come, you choose the formula, and you write your answers. I don't know if you see it. But if I ask you to use the first translation property, this is usually, when do you use the first translation property? It is only when you have an exponential function going with next to another function. I don't know if my English is making sense. Okay. If you have exponential next to another function, you can solve it using the first translation property. Let me do this. Just a random question to see if you understand me. If I have Laplace of t cos, let's say 4t, can we solve this expression using the first translation property? Can we do that, guys?
No, because you said the first equation should have an exponent, right?
Yes. That's one of the reason the formula says that if you have Laplace of exponential, they said bt, doesn't matter. Bt is just a whatever on top of the exponential of f of t. It means exponential next to any other function. You can write it as f of p minus b. I will explain what does this mean through this solution. F of p minus b simply mean solution with p minus b. But let's do it so that you can see what I'm doing here. Now, let's solve.
Let me see what you are writing. It's on the side.
Oh, it's on the side.
Yeah. Can I ask something?
Yes.
So is it always gonna be mentioned that solve this using
First point, yeah.
the first
Yes, property, translation property.
yes, or you have to understand that if the equation is having an exponent and there is another equation next to it, then you need to use the first property.
Yeah, that's if I have to answer this question, your question in the understanding way is, once you have this and this, you know that you can solve this using the translation property. Let's say the equation is simply saying solve for Laplace of this. You do have a formula for it. Do you see it? You only use the first translation property if you are being asked to use that method. Am I making sense?
Yes.
That's the only time that you use the first translation property. But if it is not asked, I will come to my formula sheet, copy, paste, and I'm done. So, the first property says it is f. When you see a f like this, it simply means the solution with p minus b. Anyway, let's write this. Let's solve this problem here using the first property, step by step. First thing to do is you solve for Laplace of the function next to the exponential by using the formula. I don't know if I'm making sense. When you solve using the first translation property, the first thing to do, you solve for Laplace of what is next to it, regardless of this exponential next to it. I don't know if I'm making sense. Like for instance here, I will solve Laplace of cos 2t. What is Laplace of cos 2t? You know that you do have a formula sheet. Laplace of cos at, it is p over p square minus a square. So if we have to apply this formula here, we're definitely going to have p over p square minus a square. Remember, a square here is 4, because 2 square is 4. This is first the solution of this. If I can show an arrow just to show you what I did. You get it. Now, what do you do next to solve? Where you have an expression of p, that's basically what this formula is explaining. The solution f becomes p minus b. What does it mean? It simply means once you are done solving for the Laplace of the function which is next to the exponential, you have to substitute wherever you see p by p minus b. Now I have to recall which one is b. B, it is simply the exponential, the power of the exponential where there is e. Now if we have to write this solution using first translation, this is how it's going to be. You'll have Laplace of exponential 5t cos 2t like this to be equal, you write the solution of this guy here, which is p square minus 4. You write like this Now, this is just the beauty of the math. That's what I'm writing now. You come down here. You say that the expression of P will be substituted by the expression P minus B. So P minus, what is our B? Our B is 5. So P minus 5. So what will be the general solution? The last solution, guys, how do you solve it? You simply substitute where there is P by P minus 5. So the solution here will be P minus 5 over, here you will have P minus 5 square.
Sorry, can I interrupt you before you go further?
Yeah.
Okay, I only understood you there. Then from there, I don't understand where you said we first start with the equation with no exponent. Then we take the formula from the table, we substitute for that equation. Can you please start from there after substituting that equation?
Okay. Do you understand that by with first principle, what I said is the first thing is we solve for the Laplace of the function next to the exponential alone, right? Which is this one. In a simple word, after solving this, what you are supposed to do, because what I'm doing here, I'm just writing with beauty, but let me explain it short and you see where I'm coming from. Once you get this, right, for you to solve the whole problem, you simply substitute now on this general solution. Wherever you have a P, you substitute by P minus B, where B is the exponential on top of E here. Like here, what I meant is, this is P, right? It is P over P square minus 4. So because I have P, I will substitute by what? P minus 5. Because down here, I also have P, I will have P minus 5 square minus 4. Now, I want to recap to avoid confusion. This is how you solve it. This is just a proper way of writing it to show that, first of all, I have this solution of the Laplace on its own. Now, I will be substituting where there is P by P minus 5. Am I making sense, you see?
I think so.
For the others, is it fine? You only substitute where there is P by P minus B. Let's say, guys, in this case, our B was negative. What will be P minus B? P minus B will be, you have P minus of the formula and then minus 5. In this case, you will have P plus 5. I hope you see what I'm doing. So, what does it mean, guys?
Sorry. So, we don't substitute anything for E to exponent T.
I want to get your question again. We don't substitute anything?
Yes, we do not substitute any formula for E.
No, you do not.
To exponent 5.
You do not.
Oh, okay. We only solve the equation next to the exponential equation.
Yes, and then the only way that you include the E, it is when you substitute by what? P minus the power of the guy that you have here.
All right.
Yes, that is when you want to solve using the first translation property. In other words, this, if you use the formula straight, we're gonna get the same answer. It's going to be P minus 5, P minus square minus 4. But it's not something that the lecture will be emphasizing much, but we just have to cover it in case something like this comes, because what is most important as we move here is going to be in Laplace transform of integral, division by multiplication by t, division by t, and convolution, like going down. This is where it becomes more interesting, where you have integration by part, but we'll get there. And I'm just glad that we started earlier, so we have time to move slow in an understanding way. Any question, guys, before I move to something else? This is how they get to this answer using the first principle. Any question? Any question, guys?
Can you please do another example?
Another example, yeah. This is good, Sisi. Yeah, thank you. Let me cook something else. Let me look for something that goes. Let me just look at the formula. Which one goes also with exponential? We have exponential, cosine.
Sorry, are we going to get this note?
Yeah, this one is recorded. You'll have it on my YouTube channel. Just now after the class.
Oh, okay. Okay.
So please, yeah, subscribe. But only these 4 classes, that's gonna be all of them from the people that will pay. I'll make the videos private for them. But for now, we're all going to have it. Okay, can we try something like this? I think I want to try it myself also to see. Okay, let's try something like this, guys, using the first principle. Let's say we have Laplace of t square exponential minus 2t. Now, because we do have exponential next to another function, you know that we can solve this using first translation property. Are we together, guys? Now, what do we do? According to the rule, the first thing that we have to do here, guys, we have to solve for Laplace of this guy alone, t square. What is the formula for it? I'm just going to scroll up so that we can see the formula. Here is the formula. T to the power n. It says it is n factorial Pn plus 1. So can we apply this formula here, guys? Can we solve for this guy here? It is n factorial. So it is 2 factorial. Do we agree? And then it is Pn plus 1. Remember, the value of n in this case, it is the power. Next, the power allocated to t. So it is Pn plus 1, which is P2 plus 1. Ooh, plus, why is it not nice? So this is what's gonna...
Okay, sorry. Now I don't understand.
Yeah,
because with my understanding, I thought we're going to solve the equation on the right, the e to the exponent negative 2t.
No. Remember?
So can you...
No, I think you need to see. Look, what does the formula say? If you have an exponential next to any other function, this is how you get translation by t. Kimet. Now, it doesn't matter the order. If it is right or left, as long as it's next to someone.
I think I missed it from the formula.
No, it's okay. As long as it's next to someone, you apply that rule. Now, what I will do here, I will write now P should be substituted by the expression P minus B. So it will be P minus of the formula and this minus 2 here, which give plus 2. So if we have to write this answer with beauty, 2 factorial, it is what again? I think 2 factorial is 2. You can check with your calculator. You have P to the power 3, like this, going with P along P plus 2. So if we have to substitute to get the final answer, you will have 2. Sorry about this handwriting, like I said, I will get my tablet next week. Yeah, it will be proper. Where there is P, I substitute by the expression P plus 2. Now, I can just put the 3 here, and this is the final answer. So what is the rule? As long as there is something next to E, you can solve it using first translation property. Do you guys agree that if I take Laplace of t sine, let's say t sine t, do you guys think that we can have the first translation property here?
Nope.
Why? It's easy. Okay, you know what I want you guys to do? I don't want you guys to think much about it. All you want to see is to see if there is E next to someone. It's not, I don't want to say it's difficult.
In this case, there is no E, so we cannot use the
Yeah,
first
you
property.
cannot use now. There's another rule that we'll be seeing. If you want to solve this case, there is what we call multiplication by t, which I want us to see as we're moving. But are we all confident with the first translation property, or we can try something else? Can we move, guys? Let me look at you even. Let me check you. Can we move? Okay, Z may say we move. Okay. What is next that I want us to do is, okay, they call it change of scale property. Again, guys. Again, this function here, you can solve it using the straight formula. It's just like they are just applying properties on how to solve them. So it means that you simply have to know which property are you dealing with. Like for instance here, the rules is simple. If you have any function that has any constant next to it, you can solve it by using the scale property. Let's do it. I don't want to waste much more time here because I know the stuff that is more interesting are coming, but let's just do this. So the first thing that we saw, it is first translation property. How do we know that we have it? We know that when we have an exponential next to another function. Now let's look at what we call change of scale property. So for the change of scale property, what is the formula? The formula says if you have Laplace of any function f of at, as long as you have a constant at. Sorry about my handwriting, guys. I know it's not that good. Like I said, we won't be having this problem by next week. We'll be fine. We'll close nicely. Now we have 1 over a f of p over a. I don't know why they're giving people so much formula where you can just pick straight from the formula sheet and solve. So what does it mean, guys? When you see a question, please read the instruction. That's what it means. It doesn't mean because it is Laplace, you just have to go pick the formula and put the answer. Make sure that you read. If they say solve Laplace, you know you pick the formula. But if they ask you to use a specific, let's say, translation property or scale property, then you know that you have to solve this by going this way. I hope it's making sense. Let's move, guys. How do we solve this? Okay, for instance, I'm just going to take the same example that they got there. If you have Laplace of sine 3t. Okay, guys, how do you know that you have a scale property? As long as you have any function. Ooh, time is running out, man. I think 15 minutes is a lot. We can do a lot in 15 minutes. A lot can be done in 15 minutes. Yes, here we go.
Are the classes always gonna be an hour?
No, my classes are normally 2 hours. I'm gonna send a new link. It's not gonna be an hour. When I'm saying 15 minutes, because Google Meet allows you to have something like an hour for each session unless you pay them. So after this, I'm gonna resend the link. It's not like it's gonna be an hour. I have a target, remember, that we have to cover, and I want us to be ahead of that. Have you guys done any math classes? I don't think school is open yet, ne? Did I answer you, Sisi?
No.
Oh, no. Let me answer your question. The classes are not gonna be an hour. The range is from 2 hours going up. Yesterday it was short, it was an introduction, but today we're going to cover what we said we're gonna cover today. So if the link closes, I will send a new link so that we can continue our class. Did I answer you now?
Yes.
Okay, thank you. What's your name, Sisi?
Zime.
Oh, Zime. Okay. I always have someone that I call usually in my classes. If you look at my previous video, I think last semester it was who again? Andile. Yeah, she was. She was the one I was calling a lot. So I need someone to be calling again. Okay, Zime. If I can re-explain this, how do you apply a scale property? As long as you have a function that has a constant here, which is not 0. I hope I'm making sense. Let's say you have a Laplace of 2t. No, I don't think this one will work. It is f of at. Yeah, it can work. It can work. It can work. Let's say you have a constant next to any function. No. This is not applicable. I'll confirm that. Now, let's look at here. As long as there is a constant inside this function, which is a, we can solve this by using a scale property. I don't know why we do that like that, but we have to do that according to the rules. The formula says it is 1 over a. So you simply you write 1 over, what is a? A is 3. If you see f big like this, the f big simply means the solution of the Laplace. Now, what is the solution of the Laplace of sine 3t? You know the formula of it. It will be provided. If you have sine, it is a over p square plus a square. So let's apply it. A over p square plus a square. What is a? A here, scholar. A here is 3. Now we are just applying formula. Now, instead of p square, that is the difference. Instead of writing p square, you will replace the expression where you have p by what? P over a. Or let me just write first to see what I'm trying to say. Normally, we are supposed to be having p square like this. P square plus a square. Remember, a is 3. 3 square is 9. Now, let me write it like this. And the expression of p should be replaced by p over a. Yeah, this makes more sense. So what is the solution now here? You will have 1 over 3, open bracket, 3, where there is p, it will be p over a. A here is 3, so we're going to have p over 3. Sorry about this handwriting. Sorry, I don't have the tablet now. It's a bit challenging, but I'm trying. P over a will be p over a is what? A is 3. Square, everything like this. Plus 9. Let me write big bracket like this. Scolo 5C. Talk to me. Guys, so far so good, because I like what is coming next. I love what is coming next, which is what is it again? Laplace using integration method. Now by here, what do? We can simplify here, doing some math. So you have 1/3. We've got 3. We have p square. P square over 9 and plus 9. So what is happening next here? We need to simplify this. How do we simplify this? How do we simplify this, guys? How do we simplify? Let me write it aside. How do we simplify it? P square over 9 plus 9. How do we do that? Okay, we can take common denominator here to be 9. Okay, let's do it old school. Let's do it the old school. Now we p square plus 9 times 9 is 81. I think so. Over 9. This is what you have on the denominator here. And remember, I'm pretty sure you remember this rule of math. If you have a over b divided by c over d, the first function do not move. The a over b remains a over b. You multiply by the reverse, which is d over c. So it's just a quick reminder. That's what we will be applying here. In which case, because here, this function here, when you expand, it basically becomes 3 over p square. This is when we expand. P square plus 81 over 9. So if we have to apply this rule here, the first fraction will be 3. Multiply by the reverse. The reverse will be 9 over p square plus 81. Yes, p square plus 81. So basically the final answer here should be 1/3. This guy here multiply by 3 times 9 over p square plus 81. Hey, any question, guys? I think the math was cooking a lot. Any question, guys? Hello. See me? Any question?
No.
Okay. I know the math was mathing. What we have to do next here is integration, Laplace transform using integral. Remember, guys, this video will be on YouTube. So if you go through it, there is something that you don't understand. Let's say you are shy to speak in class, just comment there. I'll answer it in class, because I always check my YouTube channel. So what I want to do now is, since this link is closing in the next 6, I want to close it and send the new one, so that we can do what is I know, which is most important, that you'll be seeing throughout this Laplace transform of integrals. So let me just send a link now and we can have it now. Ooh, Scala is burning. Let me send this link quickly that you can join and we can continue the class.
Can't be that nice.
He danced. It's nice.
Why didn't you dance?
I kept taking. Even though you
You keep taking it because I'm not paying attention.
Have fun. I mean, have fun. Yeah.
I'm taking the gun.
Yeah, it was made by you.
Eh?
It was made by you.
Yes, Mr. Poppy. Yeah, meanwhile, let's give others chance to join as well. Mr. Poppy. How are you?
I'm good, man.
I'm fine, my brother. Yes, let's just give like maybe 2 more minutes for the others to join. So far so good, guys. If you have any question, please raise your concern. The video will be on YouTube. Just after the class you will see it. Please activate the notification button.
Oh, this one day. At night. One day.
That means two of you, no? That means two, both of you.
What?
You
I
guys
think we can
need
start
to-
now.
It's only
55, 57. If there's nobody coming in again, we continue.
Imagine my wife one day. She's gonna be lucky, man. Yeah.
Yeah. I wonder who she's gonna be.
Are you back now?
Okay, I was waiting for Zime. She's in.
I wanna be there.
You don't want to be gone.
I want to be there. You don't let us know.
Okay, guys, I think let's go. Okay. Okay, Zime is joining again. Do you have two accounts, Zime? You join with one phone. Okay, guys, yeah. Laplace transform of integral. Don't will not allow this because yeah, it's disturbing me. Laplace transform of integral. Let me just put something here. It is Laplace transform of integral. Let me not just try to write. Okay. Here is the general form of the Laplace transform integral. One thing about Laplace, guys, this is how I want you guys to go about it. Don't try to think much about it. I want you to see, and from what to see, apply the formula that goes with it. That's all I want you guys to do. And by that way, you'll be able to solve any equation regardless of how they will bring it to you. Here's what it says. If you have Laplace integration from 0 to t of f of u du, don't worry, I know the formula looks like du what it looks like what is going on here, but it is very easy. All you have to know is the solution of your Laplace f of p should be divided by p. As simple as it is. How is the question being asked? Let me open one of the problem here. You are given whatever the function will be. That's what I said. If you are solving for the Laplace, please read the full question. Read for the instruction what is being asked. In this problem here, they say determine Laplace of sine 40 using Laplace transform of integrals. Here is the formula, and here is the question. Let's solve it to see how it works. Now, we are given Laplace of sine, let's say the example is sine 40. Okay, let me show you something as well. Yeah, I think I need to show you now so that you can see. Under this problem, they said determine using this. This same question, I'm just gonna scroll down to show you what I mean. Don't worry about this, we'll get to this one. But I just want to show you something under the problems. Do you guys agree that if I show you something like this, do I have to come in the question and say it is Laplace of integral? Hello? If I write something, look at the formula of what Laplace integral says. It says that it is integral 0 to t, whatever function you have inside here, in terms of du. Spiwe mbonani.
I don't think you need to be told in this case
Because
because already there is a du.
not even du, what I want you to see as well is the limit of this integration. When it says
Yeah.
0 to t, you know that you are dealing with the integration.
Okay, so that the limit matters.
Because this one, 0 to infinity, is something else. I will explain that as well.
Okay. All right.
Because this one, it is du, but the limit is 0 to infinity. But believe me,
Okay.
that's what I said. This chapter is easy. All I want you guys to do is to see what you are doing. You don't even have to claim. You don't have to do 10 questions. You just have to identify what you are dealing with. I can guarantee you, you will solve the problem. So you don't have to claim anything. Now, because they said, because the question is saying that solve this using Laplace of integral. So you have to transform this function here in the form of the Laplace integral. What do I mean by that? Let me show you here. You have to write it according to the formula form here. Let me show you what I mean. It will be Laplace of integration 0 to t, where there will be any sign will be sign. 4 will be 4. But where there will be t, it will be u. Where there will be next to it here, it will be du. Now you have written this function here. You have written it in the form of the Laplace integral. What is different with this case? In this case, it is already given in the form of the Laplace integral. All you have to do is to solve. Am I making sense, my good people? Hello? See me?
Yes.
Thank you, my brother. So this is what we've done. We write first this function in terms of the Laplace integral. Now, guys, this is the easiest thing ever. What you have to do is to apply the formula. The formula says that to solve it, it is f of p divided by p. Now, how do we solve it? Very easy. What is f of p? F of p, it is simply the solution of the Laplace of this guy, of sine 40. So what you do is you go to your formula sheet, you look for sine formula there. What is the answer of that Laplace? Let's do it together. We have sine. What is sine? Sine is a over p square plus a square. Let's apply it. Just by following the formula. A is what? A is 4. Let me do it like this on top. A is 4 over p square plus a square. P square plus a square, which will be 16. Now, what you got here is what you call f of p. Now, they say the solution of this case is f of p divided by p. So what you have to do is, this solution that you got here, you simply divide it by p. This is the final answer. Can't you see how easy and straightforward that it can be? All you have to do is to know which type are you dealing with. So if I can simplify this, the answer will be 4 over p multiplied by p squared plus 16. Now I'm gonna repeat again with my word. All you have to do is you solve for the Laplace of this function and then you divide it by p. That is what the formula says. Once you do that, you solved for the problem. How do you know that you are dealing with integral, the transform of integral? Either, like in this case, it will be stated, or it will be given like this. Another question, guys.
Okay, can you please go up
On this book, ne?
where you are writing? No, not on the book. Okay, here. So if we change the equation, we only change the equation. Then when we are solving, we do not use the equation.
Yeah, that's it.
Okay, we go to the first equation,
first
the
equation, we
Laplace
solve it,
equation
yeah.
that we were given.
Yes.
All right, then.
You're welcome. Any other question, my good people? Let's see if we can get something else that we can solve using Laplace integral. Let's try. Let's try anything. What do you have any idea? Can someone suggest something here? Just suggest, guys. Anything. What you see in your mind, we do it. I feel like challenging myself.
Let's do the one you were showing us down there.
You say?
Let's do the one you were showing us down there in the book.
No. It's not difficult. You see the one down in the book? You have u here. You see it? This is division by t, so I don't want to move to it yet. That's why I'm not doing that.
All right.
Yeah, it is called division by t property. That's why I don't want to go to it before teaching it. I'm not running away from it. I can't run from that. So that's why I'm thinking of something, because most of the question there, they are division by t. There is a rule to it that I need to explain thoroughly that I want to do with you tomorrow. So tonight, let's do what's on the scope. Let's see if we can cook a question. Let's say we have Laplace of, let me try something. Let's say exponential 2t cos 3t. I'm just trying something. Let's do it together. Okay, guys, let's say we are given this problem and they said we should solve it using Laplace transform of integral. First thing, we have to rewrite it according to the formula. It will be Laplace, open bracket, integration of 0 to t of exponential 2, where there is t we replace by u, multiplied by cos of 3, where there is t again we replace by u. Sorry about my handwriting. And here du. Now, how do we solve this problem? It is easy. You will be basically solving for the Laplace of this using the formula, and then you divide everything by p. Let's do it. If we have e and cos, according to the formulas, which one it is? I want to scroll up, but let me scroll up, because this formula is up here. If we have e and cos. What does the formula say? It is P minus B. What am I looking at? P minus B over P minus B square plus A square. Let's write it. I hope I'll remember it. P minus B over P minus B square plus A square. P minus B. So it is P minus B. P minus 2 over P minus B square over P minus 2 square plus A square. Plus A square. Remember, A is the guy here next to cos. So plus A square will be plus 9. So everything should be divided by P. Now you have solved for the problem. If we want to write with beauty, we're going to get P minus 2 over P square, P minus 2 square. Sorry guys, plus 9. Remember, the P is multiplying everything, né? This literally it. So this is the scope of where I wanted to stop today. We're meeting on Thursday, né? Thursday. This is what I want us to do. It is not like the class is 1 hour. I'm moving according to a scope, but my classes, they are 2 hours going up. Now we'll be doing multiplication by t on Thursday. We will do division by t. And after that, all these cases, they have a lot of cases. We will do convolutionary. Convolutionary, it comes with integration by part. If you don't remember, I'm here for that. I'll help you. And these are the 3 things that I want us to do for the next session. What is it again? Multiplication by t, division by t, and convolution. As you can see, the class will be long because this needs some clear explanation here. So for the next class, which is on Thursday, this is the 3 things that we'll be doing. Or I will see how the class understands if we are not moving. If I don't know, I will see how we're moving. Because we have to move together in the understanding way. But this is the target. And Friday we can do application on the Laplace. Yeah, literally we can do them, and you also have inverse Laplace. So the topic is very long, but the target on Thursday are the first 3. Now, before I call the class of what, please, you have a free speech. Every time when I end my class, I believe that there is a way that I need to improve. And the only time that I can improve is if you give me a feedback. So feel free to give me your feedback. If you feel like there is somewhere that I don't explain well, I can always come with a better method or better approach. Or if you feel like the example we do is very small, I can come with more example. Just speak your truth. I will appreciate that.
Can I ask a question?
Yes,
Do
definitely.
you have the previous question papers, maybe for test 1, test 2, so that when we are
Okay.
about to write the test, we can do the question papers?
I'll get them for you. That's
All
my
right,
assignment.
please.
Yeah.
Thank you. All right, thank you.
That's the only question that you have. Oh, I thought you wanted to ask me something.
Yes, for
Ah.
today.
No, I have a question also. Not a
Please.
question, but just a concern.
Yes, please.
Everything that you're saying, it's making sense, but I feel like you are moving so fast. Can
Oh,
you
that's what I
take
wanted
it
to
slow
hear.
and also do more examples?
Mm.
It was like, yeah, it's making sense, but we are flying. We are flying.
Yeah,
So can you take it like easy and then also do more examples?
yeah. That's what I was asking. Thank you. I think uh, that's what I needed to hear. So I'll move as since we are not near Hungary yet. So we'll move as not as slow as we can, but in the way that we all understand. Thank you. Because there's a time that I felt like I was fast, but I couldn't just. Thank you. That's something that I'll change definitely. But do you understand me when I speak? Do you understand the way I teach? Or if you don't, you can always say, and I come with a better way. Okay, guys, I do believe that this is it. So we meet on Thursday. So what I will do, the video is how long? The video is an hour and